Next question is: a company wants to use Amazon DynamoDB for maintaining metadata on its forums. See the sample data set in the image below. A DevOps engineer is required to define the table schema with the partition key, the sort key, the local secondary index, projected attributes, and fetch operations. The schema should support the following example searches using the least provisioned read capacity units to minimize cost. Search within forum name for items where the subject starts with A. Search forums within the given last post date time frame. Return the thread value where last post date time is within the last 3 months. Which schema meets the requirements? A. Use subject as the primary key and forum name as the sort key. Have LSI with last post date time as the sort key and fetch operations for thread. B. Use forum name as the primary key and subject as the sort key. Have LSI with last post date time as the sort key and the projected attribute thread. C. Use forum name as the primary key and subject as the sort key. Have LSI with thread as the sort key and the projected attribute last post date time. D. Use subject as the primary key and forum name as the sort key. Have LSI with thread as the sort key and fetch operations for last post date time. Correct answer is A. Next question is: a company used AWS CloudFormation to deploy a 3-tier web application that stores data in an Amazon RDS MySQL multi-AZDB instance. A DevOps engineer must upgrade the RDS instance to the latest major version of MySQL while incurring minimal downtime. How should the engineer upgrade the instance while minimizing downtime? A. Update the engine version property of the AWS RDS DB instance resource type in the CloudFormation template to the latest desired version. Launch a second stack and make the new RDS instance a read replica. B. Update the DB version property of the AWS RDS DB instance resource type in the CloudFormation template to the latest desired version. Perform an update stack operation. Create a new RDS read replicas resource with the same properties as the instance to be upgraded. Perform a second update stack operation. C. Update the DB version property of the AWS RDS DB instance resource type in the CloudFormation template to the latest desired version. Create a new RDS read replicas resource with the same properties as the instance to be upgraded. Perform an update stack operation. D. Update the engine version property of the AWS RDS DB instance resource type in the CloudFormation template to the latest version, and perform an update stack operation. Correct answer is A. Next question is: a retail company has adopted AWS OpsWorks for managing its deployments. In the last 3 months, the company has discovered that some production instances have been restarting without reason. Upon inspection of the AWS CloudTrail logs, a DevOps engineer determined that those instances were restarted by OpsWorks. The engineer now wants automated email notifications whenever OpsWorks restarts an instance when the instance is deemed unhealthy or unable to communicate with the service endpoint. How can the engineer meet this requirement? A. Create a chef recipe to place a cron to run a custom script within the Amazon EC2 instances that sends an email to the team by using Amazon SES if the OpsWorks agent detects an instance failure. B. Create an Amazon SNS topic and create a subscription for this topic that contains the destination email address. Create an Amazon CloudWatch rule. Specify AWS DOP-C works as a source and specify auto in the initiated _by details. Use the SNS topic as a target. Healing. C. Create an Amazon SNS topic and create a subscription for this topic that contains the destination email address. Create an Amazon CloudWatch rule. Specify AWS DOP-C works as a source and specify in the initiated _by details. Use the SNS topic as a target. Instance replacement. D. Create a subscription for this topic that contains the email address. Enable instance restart notifications within the OpsWorks layer and indicate the destination email address for the notification. Correct answer is B. Next question is: a healthcare services company is concerned about the growing costs of software licensing for an application for monitoring patient wellness. The company wants to create an audit process to ensure that the application is running exclusively on Amazon EC2 dedicated hosts. A DevOps engineer must create a workflow to audit the application to ensure compliance. What steps should the engineer take to meet this requirement with the least administrative overhead? A. Use AWS Systems Manager Configuration Compliance. Use calls to the Put Compliance Items API action to scan and build a database of non-compliant EC2 instances based on their host placement configuration. Use an Amazon DynamoDB table to store these instance IDs for fast access. Generate a report through Systems Manager by calling the List Compliance Summaries API action. B. Use custom Java code running on an EC2 instance. Set up EC2 auto-scaling for the instance depending on the number of instances to be checked. Send the list of non-compliant EC2 instance IDs to an Amazon SQS queue. Set up another worker instance to process instance IDs from the SQS queue and write them to Amazon DynamoDB. Use an AWS Lambda function to terminate non-compliant instance IDs obtained from the queue, and send them to an Amazon SNS email topic for distribution. C. Use AWS config. Identify all EC2 instances to be audited by enabling config recording on all Amazon EC2 resources for the region. Create a custom AWS config rule that triggers an AWS Lambda function by using the config rule change triggered blueprint. Modify the Lambda evaluate compliance function to verify host placement to return a non-compliant result if the instance is not running on an EC2 dedicated host. Use the AWS config report to address non-compliant instances. D. Use AWS CloudTrail. Identify all EC2 instances to be audited by analyzing all calls to the EC2 run command API action. Invoke an AWS Lambda function that analyzes the host placement of the instance. Store the EC2 instance ID of non-compliant resources in an Amazon RDS MySQLDB instance. Generate a report by querying the RDS instance and exporting the query results to a CSV text file. Correct answer is C. Next question is: according to information security policy, changes to the contents of objects inside production Amazon S3 buckets that contain encrypted secrets should only be made by a trusted group of administrators. How should a DevOps engineer create real-time, automated checks to meet this requirement? A. Create an AWS Lambda function that is triggered by Amazon S3 data events for object changes and that also checks the IAM user's membership in an administrator's IAM role. B. Create a periodic AWS config rule to query Amazon S3 logs for changes and to check the IAM user's membership in an administrator's IAM role. C. Create a metrics filter for Amazon CloudWatch logs to check for Amazon S3 bucket level permission changes and to check the IAM user's membership in an administrator's IAM role. D. Create a periodic AWS config rule to query AWS CloudTrail logs for changes to the Amazon S3 bucket level permissions and to check the IAM user's membership in an administrator's IAM role. Correct answer is A. Next question is: A business has an application that consists of 5 independent AWS Lambda functions. The DevOps engineer has built a CI/CD pipeline using AWS Code Pipeline and AWS Code Build that builds, tests, packages, and deploys each Lambda function in sequence. The pipeline uses an Amazon CloudWatch events rule to ensure the pipeline execution starts as quickly as possible after a change is made to the application source code. After working with the pipeline for a few months, the DevOps engineer has noticed the pipeline takes too long to complete. What should the DevOps engineer implement to best improve the speed of the pipeline? A. Modify the code build projects within the pipeline to use a compute type with more available network throughput. B. Create a custom code build execution environment that includes a symmetric multi-processing configuration to run the builds in parallel. C. Modify the code pipeline configuration to execute actions for each Lambda function in parallel by specifying the same runa writer. D. Modify each code build project to run within a VPC and use dedicated instances to increase throughput. Correct answer is C. Next question is: A company uses a complex system that consists of networking, IAM policies, and multiple 3-tier applications. Requirements are still being defined for a new system, so the number of AWS components present in the final design is not known. The DevOps engineer needs to begin defining AWS resources using AWS CloudFormation to automate and version control the new infrastructure. What is the best practice for using CloudFormation to create new environments? A. Manually construct the networking layer using Amazon VPC and then define all other resources using CloudFormation. B. Create a single template to encompass all resources that are required for the system so there is only one template to version control. C. Create multiple separate templates for each logical part of the system, use cross-stack references in CloudFormation, and maintain several templates in version control. D. Create many separate templates for each logical part of the system, and provide the outputs from one to the next using an Amazon EC2 instance running SDK for granular control. Correct answer is C. Next question is: A DevOps engineer is deploying a new web application. The company chooses AWS Elastic Beanstalk for deploying and managing the web application, and Amazon RDS MySQL to handle persistent data. The company requires that new deployments have minimal impact if they fail. The application resources must be at full capacity during deployment, and rolling back a deployment must also be possible. Which deployment sequence will meet these requirements? A. Deploy the application using Elastic Beanstalk and connect to an external RDS MySQL instance using Elastic Beanstalk environment properties. Use Elastic Beanstalk features for a blue/green deployment to deploy the new release to a separate environment, and then swap the name in the two environments to redirect traffic to the new version. B. Deploy the application using Elastic Beanstalk, and include RDS MySQL as part of the environment. Use default Elastic Beanstalk behavior to deploy changes to the application, and let rolling updates deploy changes to the application. C. Deploy the application using Elastic Beanstalk, and include RDS MySQL as part of the environment. Use Elastic Beanstalk immutable updates for application deployments. D. Deploy the application using Elastic Beanstalk, and connect to an external RDS MySQL instance using Elastic Beanstalk environment properties. Use Elastic Beanstalk immutable updates for application deployments. Correct answer is D. Next question is: an Amazon EC2 instance with no internet access is running in a virtual private cloud, VPC, and needs to download an object from a restricted Amazon S3 bucket. When the DevOps engineer tries to gain access to the object, an access denied error is received. What are the possible causes for this error? Choose 3. A. The S3 bucket default encryption is enabled. B. There is an error in the S3 bucket policy. C. There is an error in the VPC endpoint policy. D. The object has been moved to Amazon Glacier. E. There is an error in the IAM role configuration. F. S3 versioning is enabled. Correct answer is B, C, and E. Next question is: an application has microservices spread across different AWS accounts and is integrated with an on-premises legacy system for some of its functionality. Because of the segmented architecture and missing logs, every time the application experiences issues, it is taking too long to gather the logs to identify the issues. A DevOps engineer must fix the log aggregation process and provide a way to centrally analyze the logs. Which is the most efficient and cost-effective solution? A. Collect system logs and application logs by using the Amazon CloudWatch Logs agent. Use the Amazon S3 API to export on-premises logs, and store the logs in an S3 bucket in a central account. Build an Amazon EMR cluster to reduce the logs and derive the root cause. B. Collect system logs and application logs by using the Amazon CloudWatch Logs agent. Use the Amazon S3 API to import on-premises logs. Store all logs in S3 buckets in individual accounts. Use Amazon Macie to write a query to search for the required specific event-related data point. C. Collect system logs and application logs using the Amazon CloudWatch Logs agent. Install the CloudWatch Logs agent on the on-premises servers. Transfer all logs from AWS to the on-premises data center. Use an Amazon Elasticsearch Logs Kibana stack to analyze logs on premises. D. Collect system logs and application logs by using the Amazon CloudWatch Logs agent. Install a CloudWatch Logs agent for on-premises resources. Store all logs in an S3 bucket in a central account. Set up an Amazon S3 trigger and an AWS Lambda function to analyze incoming logs and automatically identify anomalies. Use Amazon Athena to run ad hoc queries on the logs in the central account.